Okay, welcome back everyone to another one of these tutorial videos. So in this video, we'll be continuing our study of the simplification procedure of context-free grammars, really in the goal of converting a context-free grammar G to a context-free grammar G prime in Chomsky normal form. So like I had explained in the previous video, the first step is removing all epsilon production rules from G. The second step is going to be removing unit productions. So unit productions, if I have my context-free grammar G here, and I have some variables, unit productions are productions of the form some variable, a single variable on the left-hand side, and then a single variable on the right-hand side as well. So, here I could have B, I could have A gives you B and A gives you S. Here I could have B gives you S. Here I could have S gives you A or B, right? Then I could have more production rules on the left and on the right. And so the goal here is to remove all of these production rules, right? I want to get rid of these guys, right? Why? Because if we go back to the definition of Chomsky normal form, right? The Chomsky normal form does not admit the possibility of unit productions, right? So it only admits the possibility of, I guess, binary productions, right? Where I have two variables, exactly two variables on the right-hand side. For production rules that have more than two variables, we'll see at the very end that there's a very, very nifty and very elegant way of converting that to just binary production rules all the way. Okay. And so this video's goal is just to sort of show you how we can go from a context-free grammar G, which has unit productions, to one which doesn't, and where of course, right? Where of course, so G's prime is without unit productions, and L of G is exactly equal to L of G prime. Okay. So how are we going to do this, right? So here's the procedure. So again, we start with an input, a context-free grammar G, and as an output, another context-free grammar G prime. Let's we don't have to assume that the grammar G is in any sort of form, right? So this sort of algorithm works whether G has been simplified without epsilon production rules or not. But we'll see at the end that there's a certain order that you have to respect to simplify a grammar correctly to get to a place where you can convert to Chomsky normal form. And really, that procedure is going to be first removing all epsilon production rules and then removing all unit production rules, right? It's not going to be the other way around. And the reason for that is because if you remember from this example here, the removal of epsilon production rules can actually lead to the creation of more unit productions, right? So this was the only unit production we had in the initial grammar, but now by removing epsilon production rules, we added two. And so that's actually why when we see the sort of steps, the order of how to do things, it's always going to start with, remove all epsilon production rules and then remove all unit production rules. Okay. But we can just assume like for this algorithm works regardless of what the form of G is. Okay. Okay. So what are the steps? So the first step is remove. So okay. So let's do this. Remove all production rules of the form A gives you A in G. Okay. So it's possible, right? Like you can't sort of forget about this edge case. It's possible that someone has sort of tried to intentionally trick your algorithm and has added sort of self-referential variables, like S gives you S, A gives you A, B gives you B. But these do nothing, right? These do nothing in terms of helping you to generate more strings. So even just removing them from G is sort of a harmless step. So this is sort of a harmless, kind of not even step one, it's more like step zero. Okay. The real first step is to find all variables that are sort of linked directly together via sort of only unit productions. So we need to find all variables A, B, and V, right, where V is the set of variables of G, such that A in some number of steps derives B, right? So you could, of course, have sort of direct unit productions or direct connections between two variables. So you could have something like, A gives you B. But you can also have something like S gives you A. And so you have two unit production rules. But what we're identifying is we're kind of identifying chains of unit productions. So those chains would be, S with A with B, but also S with B, right? Okay. And so what we do is place those uh, pairs of variables in the set V unit. Okay. So now we have sort of a set of pairs of variables, right? So we have, the set A, B, so sets of tuples, A, B, S, A, S, B, and so on, right? Where this one is sort of the sort of start variable, and this one is the end variable, okay? So we do the search, then step 3 is going to be very similar to a step in the epsilon production removal algorithm. We're just going to place all, or copy, not place, copy all non-unit productions, unit productions of P to P prime, right? So the set of production rules of the sort of unitless non-unit production rule, the simplified grammar without unit production rule is G prime, okay? And then 4, whoops, you can already see the example. 4 is essentially going to be, right? So now this is like the actual crux of the algorithm. And so the crux of the algorithm is, what have I done, right? So what I've done is, I had something like a bunch of production rules, right? So S has a bunch of production rules, and it also has the production rule, maybe A, right? And then maybe B has the production rule, B gives you S directly, and it has a bunch of other production rules. And then maybe A has just a bunch of non-unit production rules, right? So what I need to do, what my grammar simplification procedure has to do, is it has to account for the fact that I can use S gives you A, right? But if in the sequence of derivation steps, I have at some point S and then gives you A, right? Maybe I have stuff on the left and stuff on the right. Then because it's S gives you A, I know exactly what the A is going to be replaced with. It's going to be replaced with any of the things here, right? So essentially what I just need to do is I need to sort of sidestep this intermediate variable and just add the production rules that I would have eventually used with that sort of unit production rule, add those directly to the production rules of S, right? So essentially, if these are in green, then I just want to copy these guys here, right? And of course, eliminate. I've eliminated these from P prime. So they're not even in P prime. So I just have to take these guys and add them to the production rules, to the corresponding production rules of P prime. Okay. And that's the algorithm essentially, right? So for every sort of pair of variables in V unit, so AB, right? If we have something like B gives you any number of production rules, x1 to xn in P prime, then what you want to do, then add A gives you each of those directly, right, in P prime. Okay, so do this for all the sort of pairs of variables in the sort of directly uniproductionally linked variables in V unit. Okay. And so we're not actually eliminating any information or any power from the grammar because we're always sort of we're preserving how the grammar gets there. We're just taking out the sort of intermediate, the middleman, really. Okay, so let's look at this example, which has been already sort of manifesting while I was presenting the procedure. So what I want to do is I want to remove all the unit productions from this grammar G, right? So what is the first step, right? The first step is to remove any of the identity production rules. So in this case, I don't have S gives me S, I don't have A gives me A, I don't have B gives me B, and I don't have C gives me C. So I can not do anything there. I can just skip that step because everything looks okay. Now two is the slightly more sophisticated or like a slightly more complicated step where I have to find pairs of variables which are sort of unit production linked. So the immediate ones are the ones that are linked by a single derivation step. So that's here, S gives me A. So I have S gives me A, S gives me C, A gives me C, and then C gives me B, right? And then I just have to sort of consider all the sort of paths of length greater or equal to 2 that I can go from each pairs of variables, right? So in this case, S can go to A and C. Now there is an S in either of these guys, so I can just ignore that. But so here A can be replaced by A gives me C, so that would give me S gives me C again, but that's already there, so I don't care about that. Now there's S gives, right, so S gives me C seems to be the thing that's going to be useful because S gives me C, well, I can say C gives me B after that, so I also have S gives me B. And then A gives me C, I also have that I can use this to then go to B, right? Yeah, so I have what A gives me B. Right, so you can also just think of these as kind of paths in a graph. So I have, S, whoops, S goes to A, and then S also goes to C, then A goes to C, right? So that's sort of, so I have S gives me A, S gives me C, and S gives me AC, but I mean, that's just the same as going directly. Then I also have C gives me B, and so that's why I have to account for, S goes to C goes to B, and A goes to C goes to B. So that's why I add these two. Okay. So either doing it sort of iteratively here or just using a graph, that's also fine. You can also, there's also like a step-by-step algorithm that you can follow just to discover those direct connections. But typically, typically for the grammars that you're at least going to have to look at, you don't really need a more sophisticated algorithm than that. Okay. So I have my pairs of variables. Then what do we need to do? Now I have to sort of start creating the grammar G prime. So G prime is everything in G that's not a unit production. Why did that not paste? You definitely saw me copy it. Okay. All right. That was strange. So let's remove this guy and this, whoops, sorry. And this guy, and come on, this guy, and this guy, this guy. I see, it just switches back. That's so annoying. Okay. Right. Okay, great. So now what I need to do is I have to add to so for each of these pairs of variables, I have to add, say, on the right-hand side of S, all of the right-hand sides of A in P prime, right? So I have to do this for S, I have to do this for S gives me A, S gives me C, and S gives me B. So for all of them, right? So I add S gives me A, what A would give me, so A and BC, what B would give me, so B, and then what C would give me, so ABA, and then CC. Then for A, right, so that was S. Then for A, I add what's on the right of C and B. So that's what's on the right of C and B. So B and ABA, BC. And then finally, I have the one for C, right? So C gives me B, so I add to the right side of C, the right side of B, so that's just B. Okay, and then that's the sort of simplified, of course, it doesn't really look all that simple, but the simplified grammar where I don't have any unit productions.